David Wasson with CAPS. This video is going to go through the setup, startup, and operation of this commercial and industrial water chiller. Okay, the first step is to decide how you're going to transport it. We've got two provisions built into our design. The first one is integrated forklift pockets in the base of the skid that can be used for a fork truck. The second is we have a certified lifting stacking cage that has lift points at each corner, all four corners, that can be brought up to a single point lift. The center of gravity is marked on all four sides for safety. And also please note that when you're either selecting the crane or the fork truck, that the weight tag is on both sides of the unit. This particular unit weighs 11,000 pounds, so you need to make sure that you certainly have the equipment. Okay, the next part of our setup is to determine the power requirements. This machine takes 460 volt three-phase, 60 hertz power. If you look at the main CAPS product data tag, you'll see that we have clearly stated here that the MCA, minimum circuit ampacity, as well as the maximum overcurrent protection. This particular 100-ton chiller takes up 244 amps minimum circuit ampacity or 250 amp MOCP. Please note that all the CAPS built equipment has integrated breakers for both the pumps and the chiller itself. So we've got all the short circuit and overload protection contained within our package. When you hook up to your main power supply, you just need to make sure you're protecting your cable, be it through a generator breaker or through the main house power. Now that we know our power requirements, it's time to hook up the power. We're going to remove the moisture and dust seals from the cam locks. That's from ground, L1, L2, and L3. You're always going to hook up your ground cable first. We want to make sure that we've got a good ground to the chassis or to the earth on there before we start hooking up our L1, 2, and 3. Then we'll proceed with hooking up each of the lines. You want to make sure that the cables are tight, that the wire's in good shape, that there's not any loose connections or frayed wires. And you want to make sure that, of course, you're wearing the proper PPE equipment to be able to hook up and handle the power itself. I'm checking all my connections, all my cables in there. Note that this cable is not energized. Now that we have the power hooked up, we're going to remove our lockout tag out from our primary power supply. We're going to energize the machine and check our rotation. Okay, now we've energized our main power feed, so we're going to turn the breaker on and check rotation. Okay, our power lights come on, but we have our phase incorrect light is on as well. That indicates that two of our phases are backwards. That thus has the machine completely locked out. So we'll kill the power to the machine completely. We'll lock and tag out our main power source, and then we're going to reverse two leads on the incoming power. Please note that you never change the incoming leads on the cam locks while they're energized. They must be completely de-energized and the load completely locked out. Okay, we've reversed L1 and L2 here to get our phase correct. Now we're going to re-energize the power. Now we have our power light on, the phase incorrect light is off. At this point, this is our master pump switch, our pump breaker, and our main system switch. We're going to turn on our main system switch, and there's a notice here that says that we have a 1 hour lockout timer from the time that you turn the system switch and apply power to the chiller. The purpose of that lockout timer is to preheat the compressor oil and remove any refrigerant that could be trapped in the compressors. This is a manual lockout. The device installed inside the pump panel should never be bypassed. This is part of the startup routine and process. Okay, now that we've got our power energized on the main chiller and we're heating up the compressors, let's go through the hydronic side. All of our chillers have an integrated circulation pump on board as part of our package. The inlet connection, which is the female cam lock, is here. The water flows through the piping, and this is an inlet strainer here, an inline strainer with a blowdown valve here at the bottom. That catches any debris. Then you have a choice of either using our onboard pump here or locking it out by closing this valve, which is closed now here, and opening the bypass valve there to bypass the pump. That's if you're going to use the customer's pump. In this application, we're going to use ours, so we're simply just going to open the butterfly valve up. That opens up our path here. Our bypass valve is closed, so now we've formed our loop going back to our exchanger. Please note that your air bleed for your pump volute is right here at the top. When we fill the system up, we'll be bleeding air off of that. Then on the bottom of the volute here, up underneath this brace, is the drain valve for the pump volute for winterization. That's where you're actually going to drain the water out of there. So this completes our circulation of our loop. So now we're going to go ahead and get the plumbing finished and start filling the system with water. Okay, let me go over some of the hydronic connections that we have, the water connections. The 4-inch inlet right here to our pump, which we just went through, 4-inch cam Dixon connection there. This is the differential pressure switch, or better known as the flow switch. It measures the differential pressure between the heat exchanger and improves flow. As we go down here, this is the high point bleed. This is plumbed up to the top of the heat exchanger. This is how we're going to get our air out. This is the outlet right here coming off the chiller, and this is our balancing valve here that we open and close to regulate that, the flow. Each of the inlet coming off the pump, inlet to our exchanger's got a compound pressure gauge and a temperature gauge, as well as a Pete's plug, and so does the outlet. The outlet has a compound pressure gauge and temperature gauge here. Then the last items we want to point out is that we're going to hook up our fill line right here to the intake here of the valve with the check valve on it, and then this is our drain valve here. So once we connect this 3/4 inch water line up, this will be our fill line to actually start filling the chiller from the bottom to the top. We want to start with filling it from the bottom to the top to push the air out. So the water goes up, displaces the air. Because remember, in the chiller and the chill water system, you can't have any air. You've got to fill it completely with water. So we're going to start that process now and finish up our plumbing. Okay, we've completed our plumbing. We've got our outlet hose hooked up and our inlet hose hooked up. We also have our 3/4 inch water line that fills in. You know that you have the supply side. It's the one with the check valve. The other valve behind it's the drains. The other one's used for drain system. So we filled our system up. We've done some preliminary bleeding on air, and we're at about 50 psi. So that's a good starting point. Our high point bleed is right here beside on this valve. We're going to open that up. You're going to hear the air coming out. Again, as we take the air out, we're going to open up the water and let it fill in. And what we want to do is we want to get 100% water coming out of the system while we're filling it, and I'm watching my pressure here. So now we've got all the air out. Looks like I got the system there for now. Close that off, and we'll close this off. And we're going to go through a process of just turning the pump on to stir the system up to make sure there's no more air in it. And we'll do that process for maybe 3 or 4 times. Please note that you can never get the air out of the system as long as the pump is running. So when you start with the pump, you want to just let the water circulate, let all the water fall, let all the air bubbles go to the top. You cannot get the air out as long as the pump is running, so it'll turn into foam. So that's going to be our next process. We're going to turn the pump on and bleed some more air out. Okay, it took us about 3 or 4 different cycles of the pump, but we've gotten all the air out of the system. We still have about a 50 psi standing pressure, which is perfectly fine. We did the process of bleeding the air out is simply turning the switch on. You can hear the pump come on. We leave it on for 4 or 5 seconds. Let it move the water around, move the air around. If I turn it off, all the water falls, all the air goes up. We've done that process about 3 or 4 times and have gotten all the air out of the system, or most of it out of the system. So we're ready to leave the pump on and running, and it's circulating through our chiller, heat exchanger, through our pump, through our air handling unit. Now our next step is going to be to go to the control panel and actually start the chiller up and start making cold water. Okay, now we're ready to start the chiller up. We've got our crankcase heaters have been on for about an hour and a half. We've got all of our air out, our water circulating, all of our air handlers set, all of our ductwork's done. We've got everything filled up, all the air bled out. So you'll need a security key, one of these keyed security keys to get into the control panel. We don't need our hot gloves anymore because we're done with all the high voltage and sharp edges. So we're just going to open this up. This is a low voltage control panel, and we're going to go through each one of the steps here to get the machine started and get it under full operation. Okay, here's our main display here at the top. This is where it's going to give you feedback, tell you what the machine's doing. The first button I want to go over is the status button. Anytime you push status button, it's like a home button. It tells you what the machine is. And currently it says unit switch off, shutdown. It's referring to this unit switch here. So if I turn it on, you'll see that it says system switch is off for circuit 1, system switch is off for circuit 2. That's actually a software switch. It's located under the options key. So we'll turn this back off. We'll go into the options key, push it twice, and we're going to turn both of the systems on. Now they're both on, and we're going to push enter. And go back to the status. Now it says it's back off on a unit system switch right here. So the left side here is operator data. You push it one time, the operator data tells you the leaving chilled water temperature is 79 degrees and the return is 78.7. Notice both those temperatures are similar. That indicates both of our sensors are reading properly. But within that menu, you can see the refrigerant pressures, the temperatures in and out, the hours, the runtime. Again, it's all data on the chiller. There's nothing to be changed under operator data. The next button is print. The print button is if you want to plug in a printer to the microprocessor and print an alarm history. The next button is a history button, which anytime you have a fault, you push that, you push the history button. We'll go to status, back to status. We'll go to the history button, it'll do a safety shutdown. It'll tell you that there's an alarm. This machine, brand new, does not have any alarms in it. That's what that's for. Then you go back over here. Next important button you'll have is the set point button. Push the set point button. It says that it's currently set at 44 degrees. Our design temperature for all of our equipment is 45, but should you want 42, you can just simply lower it down to 42 by pushing it down. Then you push enter. The schedule advanced day button is just simply if you want to have the machine programmed to come on at 6 a.m., go off at 6 p.m. 5 days a week. The program button is where we go into and have our cutout temperatures for low pressure, high pressure. Again, that's all pre-done and pre-programmed, but it leaves the factory here caps. And then we go back to the status. Again, always use the status button as your home button. Then you have your options button. If you push it, you can change the English. There's the two system switches we just turned on. And of course, the last button is the clock button. So at this point, we want to go ahead and start the chiller up. And we've already checked that we have both the system switches turned on right there. All right, so we can go back to status. So you're going to turn the chiller on by simply turning the button to on. We start the first compressor up. It'll say compressor run. It's got 1 there. Circuit 2 is off. It's got a recycle timer on it. So the chiller will always try to slowly load the compressors up. It doesn't want to overshoot it. Let's walk over here to operator data and we'll start watching our water temperature. Currently it's coming, the return is at 79 degrees and now you see the leaving water temperature starting to drop. And you can certainly go down and look at your refrigerant pressures. Everything you need to work on the machine is contained within the main display. But we can go back to the operator data and you'll see that we're starting to drop the temperature on the leaving liquid side. And if I want to change my set point anytime, I just simply punch the set point button. I raise that up to 44. 45 degrees is our standard design that we use for our air handlers and most of our comfort cooling operations. Unless it's in a low temperature situation, you're going to typically default to 45 and you push enter. So we started up the compressors. Now we have 2 compressors running on circuit 1, and you'll continue to watch the liquid temperature drop. We're already down to 78 degrees. It'll take about a couple of minutes for it to start to continue to load compressors, but as they continue to load, the temperature will drop lower and lower. So to kind of recap, if you get lost in here, just go back to your status screen. It'll tell you what it's doing. System 1's got 2 compressors. It's waiting on system 2, even though it has a full load on it. Operator data is just information on the chiller. We talked about the print and the history. Your set point button is very important. That's how you change the temperature up or down and then enter. The schedule advance is just the time schedule turn on and off. Program is really pre-programmed for set points that we've done. And then options, the only button you're going to use there is if you want to turn the system switch off. And this is how you properly turn the chiller off. You'll turn, you see you have a choice of running it both of them off. System 1 on, system 2 off, system 2 on, system 1 off, or both of them off. We're going to turn both of them off now. Press enter, and that's going to lock out both of our machines. It's going to pump it down, store all the refrigerant into the condenser, and that's the proper way to shut the chiller down by turning the system switches off located under options, not turning the main power switch off there in the front. And that's the overview of how to start and operate